This week we are going to be looking at graphs and sort of how we can interpret what they're telling us in terms of how it's increasing, how it's decreasing. We've already talked about, right, that increasing piece, that decreasing piece, or the constant piece. But now we want to look at that in more specific detail. What is it telling us based on a given situation? And then how can we use that to sort of talk about and or predict future things? Okay, so one of the most important pieces when we're looking at a graph to use for interpreting what might be happening in the future is going to be slope. And when you take the I-Step 10, you will be given a reference sheet, and on that reference sheet, you'll be given some formulas. Okay, but it will tell you that slope can be calculated using this formula. Okay, we would use this formula if we have two good points. Okay, or it could tell us that slope is rise over run. Both of these are fine ways for finding slope. It's sort of up to you as to what you prefer or what you want to use, maybe based on what you're given. Okay, so maybe we're given this graph up here. I realize it's not perfect. We just have a general idea going on. Okay, we know that this is increasing, but maybe we want to know more specific details about what rate it's increasing at. So rate is the same thing as slope. It's just sort of talking about the label that goes with it, right? Miles per gallon. That's a rate. Okay, so if we're looking at this, the first thing that we would need to do to calculate slope is we would need to find two good points on the graph. Okay, and what I mean by that is, right, if I find the point that's right here, right, this isn't a good point because it isn't at a perfect intersection, right? That's nice, neat, whole numbers. It's obviously much more clear when you have a completely gridded response. You don't want a point that you have to approximate. You want a point that you know precisely. Okay, so if I look here, right, I could say easily that this is the point 2, 2. Assuming that everything is labeled nice and neat. Okay, we could say that this is the point 3, there's probably going to be another marker in between here, right? 3, 4. Whatever. Okay, we can find slope by counting rise over run, of counting how much we go up and how much we go over. That's one option. So I could say from here to here, I go up 2 and I go over 1. Hopefully, again, this should be review. This should be something you've seen before. You'd be given a much better graph than this, but I'm just reminding you of the ideas, right? So we could say that the slope, M is the letter we use to represent slope, is 2. Okay. Or we could use these points and plug them into our point slope form, remembering that every point is an x, y, where one of these is our first point, so I'm going to give it this small number, which is a subscript, and one of them is our second point. Okay, so using my formula, right, y2 is going to be 4 minus y1 is 2 over 3, which is x2 minus x1, right, and we get the same thing. Our slope is 2. This information then establishes whatever sort of pattern is happening, right? So if I know every single time I increase by 1, I'm going to jump 2, right? I could then predict, okay, what is this graph going to continue to look like as I move out here? Because I know I'm always increasing by 2. Okay, so I want you to use that information to try and solve a problem that's having you interpret a graph about marathon training.